In example 1, we're given that a light bulb manufacturer claims that the lifespan of their bulbs is normally distributed, and you test 20 of the light bulbs and get the following lifespans. I've already entered this data in list 1, as you can see right here. What we're going to do is we're going to ask the calculator to draw us a histogram. So to do that, I'm going to go to second y equals, which is the stat plot. I'm going to hit enter for the first one. Notice my plot is already turned on. You can see that because the on is highlighted. We want to go to a histogram, which is this one right here. So if yours is not highlighted, just cursor over that histogram and hit enter. The list, we want list 1 or wherever you entered your data in. Mine's in list 1. The next thing we're going to do is we're going to go to zoom and we're going to go to 9. So let's hit zoom, and then you can come down here and just hit 9, or you can actually cursor down. If we look at this data, it appears that this data is normally distributed. Well, we could draw this thing for sure, but we have the calculator version right here, so we're just going to go with that. If you did want to draw it, you could hit the trace button, and the trace button will give you your minimum and your maximum, and then how many, the n values, how many that there are in that range. You can cursor one to the right, you can tell there's 4 pieces of data between these two, 7 between these two, 4 between those two, and then 1 in each one of the ones on the right. And if you can hit window, if you ever want to change your change the bin widths, they're called, so the ranges, the scale here is 346.8, why not make it 350? And you can just hit graph and you can see what happens here. So it's still approximately normal. It's not perfect, but it is symmetric, fairly symmetric. Again, it's not perfect. This side should be up here a little bit. It's only off by a couple though, I think, so it's not too big of a deal. It's not really skewed heavily in one direction. So what we can do is we can write that down here. Say, is it reasonable to assume that the lifespan is normally distributed? We can say yes. It, meaning the histogram and the data, is symmetric, unimodal, so there's only one hump or bump, and there's not 2 or more. Okay, and bell-shaped. We want to make sure that that data is approximately bell-shaped. It has kind of that curve to it right there.